Okay, so these are some half-life questions and some nuclear practice. Okay, the graph below represents the decay curve of a radioactive isotope. What is the half-life? So we start with 10 grams, and I need to figure out what 5 grams is, because that's half. So here's about 5, so 30 years. What is the number of hours required for potassium-42 to undergo 3 half-life periods? So I'm looking on table N, and potassium-42 has a half-life of 12.36 hours. So 12.36 times 3 is 37.08. So this is a little different. That looks bad. D. An original sample of a radioisotope has a mass of 10 grams. After 2 days, 5 grams remain unchanged. What is the half-life? So I started with 10, and now I'm at 5. So that's half. So the half-life is 2 days. Radioactive element has a half-life of 2 days. Which fraction represents the amount of the original sample remaining after 6 days? So time and fraction, hard to read, sorry. Time is 0, fraction 1/1. It says 2 days is my half-life, so there's half. After another 2 days, I'm at 1/4. After another 6, I'm at 1/8. So it is choice A. Sorry, it's hard to read that. Which has the shortest half-life? Carbon-14, according to table N, 5715 years. That's pretty long. Hydrogen-3, otherwise known as tritium, is 12.31 years. Potassium 37 is 1.23 seconds. It's probably my answer. Phosphorus 32, 14.28 days. So it is choice C. The half-life of a radioactive isotope is 20 minutes. What is the total amount after that? So time, mass, times 0. I have a 1 gram sample. So after 20 minutes, half of 1 gram is 0.5. After another 20 minutes, it's 0.25. After another 20 minutes, it's 0.125. And 60 minutes is 1 hour, so 0.125 is our answer, choice D. What is the number of half-life periods required from to go from 1 whole sample to 1/16? So 1 to 1/2, that's half-life. Half of that, half of that, half of that. So then I count up my arrows. 1, 2, 3, 4. 4 half-lives. What is the total number of grams of a 32 gram sample of phosphorus 32 after 71? Okay, so mass and time, times 0, starting with 32. Now, phosphorus 32 has a half-life of 14.28 days. I apologize. This is not easy to read. Half of 32 is 16. So 14.28 plus another 14.28 is 28.56, and half of that is 8. I'm going to keep going down here. So add another, hold on a second. 14.28 plus 14.28 plus 14.28. So that's 42.84 is 4, plus another 14.28, 57.12, so that would be 2, plus another 14.28. Here we have our 71.4, which this is, I guess there's rounding somewhere. So it's 1 gram. Took a while, but we got there. What is the approximate half-life of radioactive material X? So half means half of it's stable, half of it's radioactive. So this right here, 5, times 10 to the third. So that's 5, 1, 2, 3, 5,000. Be careful. Careful. Which sample will decay the least over a period of 30 days? So gold 198 has a half-life of 2.695 days. So that's going to decay a lot. Iodine 131, 8.021 days. That's also going to decay, significantly. Phosphorus 32, 14.28 days. And how about radon 222? 3.823 days. So which is going to decay the least? The one that has the longest half-life, so choice C. Keeping going. It's loading. Okay, read. Uh-oh. Okay, there we go. Determine the fraction of an original sample that remains unchanged after blah, 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 blah. Okay, so fraction, time 0. Okay, so the half-life of radon 222 is 3.2823 days, according to table N. So another half-life, and then we're just going to add 3.823 plus 3.823. I'm going to get 7.646. Oh, look, 1/4 we wanted. If a radioactive material were cut into pieces, what would happen to the half-life? Nothing. It won't be changed by cutting the sample size. Uranium-238 is solid, is naturally radioactive. As it decays, one of its radioactive. Okay, so write the decay equation. Radon-222. So radon-222. Radon is 86, which you actually don't need. Yeah, it is 80. No, sorry. Radon is 86. Yeah. So you don't have to put protons, but I like to because it helps. And it's going to decay into. Oh, we're doing the decay of radon 222. So radon 222, using table N, is an alpha, 4/2 alpha. So then I'm going to say, okay, so down here we're going to have an 84. And this is going to be 218. So who is element 84? That's polonium. Okay. Half-life is that. Okay. So time and mass. So time 0, mass is 1 gram. Okay, so the half-life is 3.82 days. So half of 1 is 0.5. Add another 3.82 plus 3.82 is 7.64. Half of that is 0.25. Oh, that's it. So our answer is 0.25 grams. Okay. All right, so you got to read this whole thing. How is the radioactive decay of krypton 85 different than the radioactive decay of americium 241? It's from the Chem Matters. Wow. Okay, so the decay of krypton 85, let's see. Alpha particle emissions from americium 241. So let's see, krypton 85. Is that on table N? Yeah, krypton 85, according to table N, is a beta. So how are they different decay modes? Explain why nitrogen 16 is a poor choice for radioactive dating of a bone. Bones that were living need carbon 14 and nitrogen not in living. I mean, they are, but not in the same amounts. Carbon 14 is used for dating of bones, not, well, okay, so I'm going to go back. I'm not going to say that nitrogen 16 is not in living things, because it is, but I mean, living things contain carbon. So you definitely need that. And I think that's it. All right. If you have any questions, please reach out. Thank you.